Okay, you should be seeing the whiteboard. If someone could just shout out yes, that would be good. You can unmute a mic.
Yes.
Okay, good. Thank you. All right, so let's start with the NaOH reaction. That is ionizing or reacting to produce the Na plus, aqueous, and the OH minus, aqueous. Now, this whoops, I guess I ended up drawing a line through this. Sorry. Aqueous. Okay. So this is an exothermic reaction. That should be solid for you because there's been so many videos at this point about this reaction. And that means that energy is released during the reaction. If you were holding a cup of water in your hand and you added the NaOH to it, you're going to feel the glass is going to get hot. And that's because in the process of this reaction, energy is being released. So we start out with the NaOH at a higher potential energy than the two products. So if I was to draw this in a graph form, we can put energy here. We could call this potential energy if you want of the reactants. All right, and I'm just going to draw a line somewhere, and then this is going to be the NaOH here. And at the end of the reaction, we're going to have a new platform for the two products, but it has to be lower than the NaOH because energy's been released. So this is going to be the Na plus plus OH minus here. All right, and if we draw a line over to the vertical axis, this is E2, and this is E1 where we started. Or you can call this PE R, and this is PE products. All of this means is exactly the same thing. If you take a difference here, we're going to call this delta E, or it could be delta PE from the difference of the products minus the reactants. And this is going to equal E2 minus E1. That should not be confusing. We're talking about this point. If this is 0, all right, and we're talking about this point, and we're simply subtracting E2 from E1. And you can see E2 is closer to 0. So this is going to equal a negative value. The negative sign means that energy was lost or energy released. Where did it go? It is the kinetic energy that enters the surroundings. And that's why the cup would heat up in your hand. All right, now, if we reverse this reaction, so now we're talking about a scenario where we take Na plus, that's aqueous, and we're going to add it to OH minus, aqueous, and we're going to make NaOH as the product solid. All right, and you guys know about this. You just aren't thinking about things that we talked about at the beginning of the year. I mean, if you were actually going to reverse this reaction, what do you have to do? You'd have to take the beaker that has the solution in it and put it on a hot plate. And you'd have to turn the hot plate on and drive this thing in reverse. So if we draw the graph for this, and again, you can label this how you want. You just need to understand the vertical axis has to do with energy or the potential energy difference. In this case, we're starting with the two ions here. And we have to drive the reaction in reverse, because the Na plus and the OH minus are lower in potential energy than NaOH is. So we'll put the NaOH here. And we have to drive this up. All right, now if I come over to my vertical axis, this is going to be E2, and now this is going to be E1 here. And when I take the difference, I'm going to just move this up. Then it's going to be delta E is equal to E2 minus E1. And you can see when you look at the vertical axis that E1 is most definitely less than E2. So this is going to be a positive number. And the main thing that you got to realize about this is that the two delta E's are equal. So the delta E, delta E for the forward reaction is equal to positive delta E for the reverse. I can do it this way. So the forward, we'll just call it F for forward. And then this is going to be R for reverse. Okay, now, so in other words, these two numbers are the same. This and that delta E they are the same. Otherwise, I can tell you this, the law of conservation of energy doesn't work if that's not the case. These two numbers are the same. Remember, the negative sign is just telling you direction. So the forward reaction, the energy is coming out and it is entering the surroundings as kinetic energy. So the glass of water would heat up in your hand, and with the reverse reaction, if it was to happen on its own and you were holding a glass of water, you're going to feel it cool down because the surroundings is going to have to provide the energy to drive this up. All right, and a few minutes ago I gave you the example that if you're going to actually do this in real life, you would actually have to put the beaker on a hot plate and drive this reaction in reverse. So, and that's what I'm referring to over here, where I'm saying that if you're going to do this in reverse, you're going to have to provide a source of energy in order to elevate the reactants to the level of the products. All right, with that, I'm going to conclude this particular video.